Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Addition of high to an alkene with an allylic iodide present using X is high in CCl4. Moving on to the next step. Identify the starting material. The compound is allyl iodide, H to C is equal to CH, CH2I, 3 iodoprop, 1 Na. It contains both a carbon-carbon double bond and an allylic Ci bond. Moving on to the next step. First equivalent of high adds to the double bond. By Markovnikov's rule, H adds to the terminal carbon, CH2 is equal to and I adds to the internal carbon is equal to CH, giving CH3, CH2I, 1, 2 diodopropane as the initial addition product. And for the final step. However, with X is high present, consider what happens next. The allylic iodide, Ci bond at the allylic position, can undergo substitution or elimination. More importantly, note that the first addition of high to H to C is equal to CH, CH2I following Markovnikov's rule gives CH3, CH2I. With X is high in CCl4, nonpolar solvent, ionic conditions suppressed, the reaction proceeds via addition followed by elimination of high or direct substitution. The allylic Ci in the starting material can be displaced, and the double bond reacts with high. Actually, the key insight is that allyl iodide, H to C is equal to CH, CH2I, with high first adds across the double bond by Markovnikov's rule, H plus adds to CH2 is equal to giving CH3, CH, plus CH2I, secondary carbocation, then I attacks to give CH3, CH2I. This is option A. But with X is high, the geminal or vicinal diide can lose high to regenerate an alkene, or more relevantly, the 1,2 diide, option A, reacts further. CH3, CH2I with X is high, the Ci bonds are present, and the product can undergo dehydrogenation to form CH3, CH is equal to Chi or similar, then readdition. Reconsidering the mechanism with X is high, the correct interpretation for this classic problem, H to C is equal to CH, CH2I plus high, first addition, Markovnikov, CH3, Chi, CH2I. Then the second equivalent of high reacts with the allylic iodide via an SN2 or the diodo compound loses I2 or high, ultimately giving to iodopropane, CH3, CH3. The allylic iodide under high undergoes, the vinyl allylic system equilibrates, and the thermodynamic product with X is high is to iodopropane, CH3, CH, I, CH3, a secondary alkyl iodide, which is the most stable product. The mechanism allyl iodide plus high gives allylic cation, CH3, CH is equal to CH2, plus, after loss of I from allylic position assisted by high, which is resonance stabilized, then I attacks at the more substituted carbon, secondary, to give CH3, CH, I, CH3 as the major product. Why other options fail? Option A would be the kinetic Markovnikov addition product, but not the major product with X is high. Option C1 iodopropane is anti-Markovnikov, not favored. Option D1, 3-diodopropane has no reasonable mechanism here. Therefore, the correct answer is B. Therefore, the correct answer is option B.